Greetings! Time to show you the integration work I've done in preparation for putting the system inside an enclosure, which I've already selected. The entire system resides here on this aluminum plate. The plate, just for information, is 25 centimeters in this axis and 16 centimeters like this, so roughly 10 by 6 inches, and it will fit very well inside the proposed enclosure, which you're going to see in the next video. Everything is screwed down, and wherever heat needs to be dissipated, there's some thermal interface or thermal pad between the elements and the plate. The elements that need cooling are, of course, the power amplifier, which dissipates around 60 watts of heat through its body, and the DC-DC converter right here, also screwed down against the plate with some thermal interface to make sure it stays in a low enough temperature. Everything else doesn't require special like conductive cooling, but of course it radiates heat, so I'll have to think of something good to move the air inside the box. Okay, so obviously the different elements, I think by now you should know them. This is the transverter. It includes the LO synthesizer, LO tripler, and the transverter board, all inside a single box. And at the end here, towards the dish feed, transmit port and receive port. A transmit port obviously goes through this gain block. I need an attenuator here. I put 6 dB total. And through this 20 dB, well, a little less than 20 dB of gain, and into the input of the power amplifier and out. For the receive path, well, it all happens in there, and there's a low noise amplifier at the feed point outside of the box, which we don't see. Also outside of the box, at the feed point, is the coaxial switch. So there will be 2 lines coming in inside this box, the receive line and the transmit line coming from the amplifier to the feed point. Okay, so that's the 10 gig side. On the low speed side, the IF frequency side, it's the 2 meter port here. I have my transfer relay attenuator right here. So this will go to the rig down in the shack. And so transmit and receive through this attenuator and then to the 2 meter port inside the transverter. Now for controlling everything, I have my Raspberry Pi Pico controller board here with the solid state relays to switch the transmit and receive channels in sequence, of course. The 10 MHz oscillator, the OCXO, it's ovenized. It's inside this foam hood that I created to give it a bit of insulation from the outside world, particularly when the temperature is below freezing. It will keep this thing warmer. I measured around an 8 degrees Celsius difference between air and inside the hood there, just to help the oscillator a little bit. So the other thing to mention is this board here. As you know, I'll have an actuator to move the dish, and this is the H-bridge to control the actuator. We see it here. It's the back of the board. So there's not much to show. And everything is interconnected to the outside world using DB9 connectors, which will connect to the enclosure, and then it will have waterproof connectors on the enclosure. You'll see that in the next video. So these are my connections to the outside world. The power, the control, the actuator, and even the feed point power for the low noise amplifier and the relay. Everything is included in these DB9s. I have fused the power amplifier with a 10 amp fuse just to make sure this thing draws around 7 amps. Wanted to make sure it's protected in case of a surge. Also, if there's a short on that amplifier, the DC-DC converter can provide a lot of juice, up to 15 amps at 10 volts. So it's best to protect what could short, dead short, just to make sure. The actuator arm H-bridge is also fused You can't see the fuse, but there is a 5 amp fuse just in case something goes wrong with the motor there, the actuator. I have 2 temperature probes. One will measure the air temperature, so it's loose here. And the other one is already fastened to the power amplifier near the output. And it measures the case temperature on the power amplifier. So these two are I2C driven, and they are LM75 temperature sensors. I also have a pin diode detector on the monitor port of the 10 gigahertz amplifier. This connector here, the gold connector, I created a pin diode and I send the DC voltage to the controller board, so the ADC, analog to digital converter, can measure a relative amount of output power going out using this monitor port here. So I will know when I put out power. I think I've covered everything, so it gives you a good idea of where everything is going. Like I mentioned before, in my next video I will show you the enclosure I've selected and how I've integrated this inside the enclosure. So all for now, see you soon. 7-3.